Alright guys, this is week 3 of distance learning, and we're going to be talking about piecewise functions. So again, here we are, week 3. Our topic is piecewise functions. Alright, so we've actually seen some piecewise functions already. It's been those crazy graphs where you've got one line and then all of a sudden a sharp turn and then another line and then maybe a curve. So let's go ahead and take a look at what those are all about. So here, a piecewise function f of x, what it's going to look like is we're going to have this function f of x, and essentially it's going to be a combination of other functions. So we're going to go ahead here and we're going to say it equals, and we're going to open a brace. Now here, these pieces are going to be other functions, right? And it could be anything. So I'm just going to use placeholders here, right? It's going to be g of x, right? And then maybe h of x, right? Now here I've broken it down into 2 components, but it can be 3, 4, 5, however many components you need to define your f of x function, okay? Now next to each of these, we're going to go ahead and put a comma, and what we actually have to do is define the interval on which we're going to refer to the function g of x, and an interval which will refer to the function h of x. So here I'll just go ahead and put, x is less than a. And then maybe for h of x, we're going to go ahead and say that, x is between a and b, right? Now what's important here is just when you define the intervals, they don't overlap. If they overlap, it'll cease to be a function. Okay, so generally speaking, that's what we talk about when we're talking about piecewise functions. Now, we want to make sure we know how to do 2 things with piecewise functions. We want to be able to graph them, and we want to be able to read them from a graph. So let's go ahead and dive in and take a look at some examples. All right. All right. So if we go ahead, take a look here. Here we've got a problem where we're asked to graph the piecewise defined function. And we're asked what is the domain and range, and over what intervals is the function increasing or decreasing. So I'm going to go ahead, I'll do each of these examples differently, okay? So we'll start here, and we'll begin by doing a, okay? So here, we've got this function f of x, which is defined as 2x plus 5 on the interval from -6 to -2. It's defined as 2x squared minus 7 when x is between -2 and 1. And it's -4 minus x when x is between 1 and 3. So I'm going to go ahead, I'm going to go down here and give myself a nice coordinate plane to work with. Okay. So first let's go ahead and put our axis here, right? So here's my y-axis. Okay. And we'll go ahead and make this one our x-axis. Okay. Nothing too exciting. Okay. Now here, the first thing I want to do is graph this line, 2x plus 5. So I'm going to save that and switch colors, just so we can keep it nice, neat, and organized. So here in green, I'm going to do 2x plus 5 between the values of -6 and -2. So what I find really helps is if you plug in -6 into that function and plug in -2. So 2 times -6 is -12. Plus 5 is -7. So I'm going to get the point -6, -7. So I'm going to go over 1, 2, 3, 4, 5, 6, and I'm going to go down 7. Here's the point -6, -7. Okay? Now you'll notice because this is an or equals to symbol, I've done a closed circle there. So there's my closed circle. Okay? Now I'm going to plot the point -2. So I plug -2 in. 2 times -2 is -4. Plus 5 is 1. So I know at -2, I'm at +1, and again it's or equal to, so that point is included. So now I just have to go ahead and connect those two using a line. So if I go ahead here, there is that portion of the graph. Okay, so that's what it's going to look like. Okay, now all of a sudden I've reached the end of that domain, so I'm going to go ahead and I'm going to switch colors. So for the next part, I'm going to do 2x squared minus 7, and that's going to be between the values of -2 and 1. Now what's nice about this is you'll notice 0 is in that interval, so I can actually use transformations to graph this function. Okay, so I know at 0, the vertex is usually at 0, 0, but this -7 is going to move it down 7 spaces. Okay, so I know here at 0, it's at 7. Now, because it's tighter and taller as a function, because it's vertically stretched by a factor of 2, I'm going to go back 1, up 2, right? And then usually I would go back 2 and up 4, but this time I'm going to go back 2 and up 8. And if I do that, I actually end up right on top of this point here. You'll notice I'm using an open circle because it's not included on the orange function. But that's okay. If it was included, it wouldn't be a function, even though those 2 points overlap. Okay? And then I'm just going to go ahead and mirror this. I know it's going to go right here, again with an open circle. Okay? So now I can go ahead and connect that and make my parabola. Okay? So it looks like that. Okay? Now for our last section here, all right, we're going to go ahead, and let's go with red this time, and we're going to look at this last part, which is -4 minus x. -4 minus x. And again, this is just linear, so I'm just going to plug in the points 1 and 3, and you'll notice that those are both or equal to, so they're included. So if I plug in here, -4 minus 1 is -5. So here I am at 1, I'll be at -5. So here I get a nice red closed circle. And then I actually know the slope is just -1, so I just go down 1 over 1, down 1 over 1, until I hit 3. But I'm just going to plug 3 in. -4 minus 3 is -7. So at 3 I'm at -7. Again, closed circle. And I'm just going to connect it there. Okay. So this is a graph of that first piecewise function. That's what it's going to look like. Okay. Not too bad. Again, you can see it continues to be a function because for each input there is a unique output, and it would pass the vertical line test. All right. Let's go ahead and take a look at the next example. Go ahead and save that. We'll go over a page. Now we're going to do B. And B is very similar. Okay. It's just instead of having a quadratic, we actually have a constant function here. So I'm just going to go ahead and give myself a nice coordinate system, right? Here's my y-axis. All right. Here's my x-axis. And we're just going to go ahead and graph this, okay? So here I've got from -4 to 0, this function is constant at 3. So from -4 to 0, this function just stays constant at 3. So I'm going to go to -4, 3. All right, I'm sorry, that should be an open circle. -4, 3, so that should be an open circle. All right. And then it's going to go to 0, where it will also be 3. So again, I'll go with an open circle, and I'll connect them. Okay, clear as day. Now here at 0, the function jumps, and it goes to -x. So if I plug in 0, I'm at 0, 0. Right, closed circle. Sorry, excuse me, I'm going to go ahead and save and switch colors. Let's go ahead here, orange for this part. Now, so it's 0, I plug in 0, and I get 0 out. So I get a closed circle here at 0, 0, and -x. So it goes down 1 over 1 until I hit 2. So down 1 over 1, all right, and then down 1 over 1. And again, this 2 is included, okay? So I can go ahead and connect those. Now you notice there's a jump in my graph. That's fine, not a problem at all, okay? And then finally I've got 3 minus x for this last portion. So if I do 3 minus 2, I'm going to go ahead and get 1. All right, so 3 minus 2 is 1. So here I am. This is going to be an open circle, right? Because it's not included. And then 4. 3 minus 4 is -1. So 4 I'm at -1. And again, open circle and connect it. Okay. Now you might ask yourself, when are these functions practical? And they're actually used quite commonly for a few things. First and foremost, payroll. So you might get paid a different rate depending on different times that you work in the day, or if you exceed 40 hours, you might get time and a half. They're used for car transmissions to show output at RPMs for various gears that you might be in your car. So again, these are fairly practical things. Okay. Now I'm going to go ahead and I'm going to go back and answer the questions now that I have my graph. So if I go back here to this first one now, it wants to know the domain, the range, and what intervals the function is increasing or decreasing. Okay, so let's go ahead and just list that information over here to the left. Now the domain, you can see if I were to squish this function down to the x-axis, it's going to go ahead and it's going to run I'm going to switch colors here, from right here, right, all the way over to here. So my domain is from -6 to 3, and since those are both closed circles, they're going to go ahead and get brackets. So my domain is going to be from -6 to 3. Okay, and I could express that as an inequality as well, that'd be fine. And you can also read this, right? When you look over here, you can see everything is accounted for. It goes from -6 to -2, -2 to 1, 1 to 3. So my domain is -6 to 3. Now, less obvious is the range from the description of the equation. But if I look at the graph, I can clearly see the range, right? It's going to go as low as this point, -7, and as high as this point, which is 1. And again, they're included, right? Because there is a closed circle there for those, for at least one part of the function. So the range is going to go ahead and be from -7 to +1, okay? Now we want to take a look at intervals of increase and decrease, okay? So if I'm looking for my intervals of increase, right, and these should always be parentheses, okay? So increasing, it starts increasing right here, right, and continues to increase, right, all the way up to here, and then it's also increasing right here. So those are my two intervals of increase, and I want the x values. So my intervals of increase, parenthesis, it's going to be -6 until it reaches -2. Okay, now I get that sharp point where it turns down, so I close my parentheses. And then the second interval where it's increasing is from 0. Again, we want the x value. So from 0 until 1. So there's my interval of increase, and that should be a parenthesis. Okay, does that make sense? And then for decreasing, we're going to be looking at essentially the rest of the interval, right? So it's decreasing along that orange line and that remaining red line. So that orange line appears to be from -2 to 1. I'm sorry, -2 to 0. Right? And then again from 1 until it ends at 3. Now again, you'll notice if you add the increasing and the decreasing parts, with the exception of the fact that they're parentheses instead of brackets, it will add up to the whole domain. Okay? So hopefully that's pretty clear for you guys. If I were to go and take a look at this one, same idea. You go ahead and do the domain and the range. Here the domain, if I squish this down, I can see that it runs from this point, excluded, to this point, excluded, but it accounts for every single point in the middle, right? So even here I've got an open circle, but here it's closed, so it's still accounted for when x is 0. So my domain will be from -4 to 4. All right. Sorry, it should be a parenthesis, so the domain is -4 to 4, because those are open circles, they get parentheses. Now the range is going to be a little bit more interesting, okay? The range, we're actually going to use a set to describe it, okay? I could do intervals, but I'm going to go ahead and do a set to describe my range. Now my range, if I take a look here, it bottoms all the way here at -2, and I have values all the way up to +1, right? If I squish the orange part and the red part, it goes from -2 to 1. Now the -2 you can see is included, and the 1 is excluded, okay? So I'm going to write an inequality here, all right? I'm going to put -2 less than y, right, less than 1. Now remember at 2 it's included, so I go ahead and I make it less than or equal to there, all right, to account for the fact that -2 is included. Now I'm going to put a comma, and you can see it just jumps. It jumps to right here, which is the value 3. So those are the only numbers I can get for my range. I can get numbers between -2 and 1, including -2, or I can get 3. Those are the only possible outputs, okay? All right, so the next type of problem they're going to ask us to do is to actually take a look at a graph, and from the graph, we need to go ahead and come up with the function, okay? So we're going to go ahead, we're going to take a look at this graph here, and we can see that it's got 3 distinct parts, right? So I've got this portion here, right? I've then got another portion, right, which is right here. And then finally I've got a third portion, right, that is going to be right here. Okay. Now it should be worth noting here that second purple point, what appears to be -2 for the x value. So I'm at -2, 7. I made that a purple point, but I could have just as easily made that a green point, okay? So here's my function. Now what I need to do is essentially just write my equation. Now because there's 3 points, I'm going to go ahead and start by writing f of x equals, I'm going to go ahead and give myself room for 3 parts to this function, okay? And I'll go ahead and I'll color code this the same, but you don't have to. You can just do it all in the same color. So this first part, well, this is a constant function. So I can go ahead and say, well, I just know at that portion it's going to equal 7. Now when I look at the x values there, that's from -5 to -2. So it's going to equal 7 from -5 less than or equal to x less than or equal to 2. And I used or equal to because those are closed circles. Okay. Now the next portion, okay, we're going to take a look. This one is a linear equation. So this is y equals mx plus b. I can see here that the b value is going to be 5. That's the y-intercept. And I can read the slope between any 2 points. It doesn't really matter. I'll go ahead and go from here all the way over to here. So you can see I'm going from 2 up to 7, so that's 5. And then my run is from -2 to +3, which is also 5. So if we take a look, over 1, down 1, over 1, down 1, I can see my slope is just -1. Okay, so this will be, I can do -x plus 5 or 5 minus x. I'm going to write it as -x plus 5, so it looks more like that mx plus b, but again 5 minus x would also be appropriate. Now here, this 2 is not going to be included because I included it on the last one. If I were to make it or equal to here, that would be a real problem because then it would no longer be a function, even though the points overlap. It's just really bad form. And that's going to go all the way until my x value of +3. So 2 less than x less than or equal to 3. Okay. And then here, I'm going to go ahead and do this last part in orange. Now this one's going to be a little bit harder to read, so I'm going to have to do a little bit of scratch work on this one. Okay. Again, I can see that it's linear, and I can figure out the slope, right, between any 2 points. Doesn't really matter to me, but this point looks pretty easy to read. This is the point 6, and then that appears to be 9, and then this point down here is going to be 4, 5. Alright, so if I make my triangle, right, from 4 over to 6 is 2, from 5 up to 9 is 4, so my slope m equals 2. Okay, so I know for each of these, I can go ahead and go down 2, back 1, down 2, back 1, down 2, back 1, and then down 2, back 1. And so it would intersect right here if I were to keep following that pattern. And I can see that that is -3. I'm going to verify that algebraically just so you can see. So I know here that y equals mx plus b. Alright, I know the slope is 2. I'm just going to pick one of my other points there. So I'm going to use the point 4, 5. So I plug 5 in for y equals 2 times x, which was 4, plus b. I get 5 equals 8 plus b. I subtract 8 from each side, and I can verify that b was in fact -3. So now that I know my slope and my y-intercept, this will be 2x minus 3, and that is between the values of 4 and 6. So 4 less than x less than or equal to 6. So I've gone ahead and written my piecewise function there. I've verified everything algebraically. I feel really good about it. Okay. Example B I'm not going to do because the video is already getting long. And you can email me with questions or if you want to see that. Now one thing worth noting is I will go ahead and also show you how to graph these on Desmos in a separate video. Alright. But go ahead and take that quiz. Email me if you have any questions. For this one you're going to have to upload some pictures. So be ready to take some screenshots or take a picture of some work you did on paper. Alright?